This is Dan Turchin from AI and the Future of Work. Welcome to this month's highlight episode featuring 4 great previous guests discussing AI safety. As you know, we're using 11 Labs to digitize my voice for these special episodes. The Real Me approved the content and, of course, approved the digital twin. Let me know what you think in the comments. Welcome to this special National Safety Month edition of AI and the Future of Work. Observed every June, National Safety Month is a reminder that creating safe workplaces is a shared responsibility. For those of us building AI systems, it's a moment to reflect on how technology can reduce risk, not add to it. You'll hear insights from 4 amazing past guests, Silvio Savarese, Navindra Yadav, Ben Kaz, and Eric Siegel. Each of them brings a unique perspective on how AI is helping humanize work and protect employees and their data. Let's start with how large organizations are approaching AI safety at scale. And our first guest is Silvio Savarese, Executive Vice President and Chief Scientist at Salesforce. He leads AI research focused on building trusted systems that prioritize privacy, security, and responsible innovation. Listen as he explains how Salesforce structures its research efforts to make sure AI development stays aligned with core safety principles, even in highly complex environments.
One of the other things that we've taken into account when we're designing AI for humans is what could go wrong that might have unintended implications and potentially ways that could harm humans. Sometimes we talk about, the ethics of AI and being very cognizant of what could go wrong and how it might impact the end users. What's your perspective, or even your team's perspective, on what it means to exercise AI responsibly?
Yeah, in short, it means that we want to build an AI that it's safe for users to consume. So this is the short answer. The longer answer is we want to make sure that the AI is compliant while we define the trust AI principle. And this is actually the work that we are doing in collaboration with our partners in ethics teams, with Paula Goldman and other collaborators in Salesforce, where we really work closely to understand what are the most important principles to guiding a safe AI, a trusted AI. And some of the principles include, first of all, accuracy. So deliver verifiable results that can be balanced, accuracy, precision, recalls of these models. So this is very important. And this is very important for enterprise, because at the enterprise level, you cannot actually afford mistakes. So if you want to generate an email that advertises a certain product, you don't want to, tell wrong information about this product, right? So it has to be factually correct. This is very important. The second thing is about safety. So make all effort to mitigate biases, toxicity, any kind of harmful output. And this requires a lot of work behind the scene in conducting biases, explainability, and robustness assessment. And this is also where red teaming is very important, this kind of phase. It's also very important to protect the privacy of any information that can be potentially exposed during this in the process of generating content. And this is particularly true when it comes to generative AI, because we don't know exactly what kind of content can be produced, and the type of data that we inject in a training process cannot absolutely contain any information, private information about users or customers. There's also an aspect of honesty and transparency. So when collecting data to train and evaluate models, we need to respect data provenance, ensure that we have the right consent of using data. So with customers, we definitely make sure that first of all, the default is that we don't use any customer's data for training, for building models. Mark Benioff has been saying, customer data is not our product. This is something that we take very seriously. There are situations where we do have pilots with customers. In this case, the customers might opt in sharing some of the data, but we do make sure that this data is never used for training models, because we never know how this generative model can spit out what we call regurgitate. It's not a very appetizing word, but it actually makes the concept clear. So regurgitate the private data back to the output of a generative AI. Also, we care about empowerment, recognize cases where AI should play a supporting role to the humans, augmenting humans, helping humans in situations of where there is additional help, additional support. And finally, sustainability. This also happened to be one of the values of Salesforce, but we strive to build models which are not only accurate, but also have an opportunity to reduce or contain the carbon footprint.
Completely unsolicited compliment, but Salesforce is way ahead when it comes to AI trust and safety. A really good model. I'd encourage, we can put a link to this in the show notes, but the Einstein trust layer lays out a really good, really mature framework for how to think about these things. So I like the comment you made about Benioff and, the customer's data is not our product. But through Einstein, you do let customers, I don't know if it's through RAG techniques or fine-tuning a model, et cetera, but you do let them introduce their own data that they own, which obviously can't then be shared with other tenants. My question is, one of the challenges that AI-first vendors have these days is that there's a lot of credible finger pointing that can happen when something goes wrong. The customer says, Salesforce, I trusted you to not let the model whatever, hallucinate, introduce bias, etc. And the vendor, certainly not pointing a finger at Salesforce, but you can credibly say, we own the platform, we own the algorithms, we told you how to use it, but you introduced the data that had the encoded bias in it. Everybody's pointing a finger, and yet, ultimately it's the end user, the customer, etc., that ends up being, the unfortunate, where the outcome of these biased outcomes ends up the user suffers. How do you think about who owns ultimate responsibility when there's plausible deniability all around the table?
Yeah, this is an excellent point. But I think that what we need to, it's important to make a clear difference between the consumer space and the enterprise space. So to actually create separations between these two aspects, although of course there are some area of overlap in between these two spaces. But the thing is, most of the large language model that's been deployed has been very popular so far, has been dedicated for in the consumer space applications. And, for instance, for companion AI or for as an assistant, you help me write an essay, let me find this kind of information from the web, write a summary for me. So this is, helping consumer in performing certain tasks, making them more productive, more effective, more efficient. In this case, large language models needs to absorb a lot of information, right? Because in order to be spans from one task to the other, in order to span from, let's say, literature to Shakespeare to, science to how to grow a bonsai, you need to have all possible knowledge in this planet. And typically, this knowledge comes from the internet. That's how those large language models train from. So from internet data, some of this data, might be subject to some copyright laws that leads to some issues with some legal issues. Some other might contain some biases. Other might contain some toxicity. So at the end of the day, it's very difficult to control what the output can be when all the data gets fed into the models. In the enterprise space, the needs are different, right? You have very use case specific situation. The use cases are very specific. The tasks are specific. The domain can be specific, right? You operate in a CRM, you operate in a financial service, you operate in healthcare. So you don't have to include all possible, domains in one single model. So there's an opportunity for building models which are much more specialized. In fact, could be smaller than those huge, gigantic large language models. And when you build smaller models, you also have more control of the data that you use in training. So you still want to have this kind of conversational capabilities, which are important because that's what makes these models, this generative AI, effective in practice. This ability to converse with AI, which is the new breakthrough that we have seen over the past years. But at the same time, the type of output that we are expecting from the models can be aligned with a specific task. And in this case, you can use much smaller models, and we can train those models in data that is much more controlled. So this allows us to have, to reduce hallucination, reduce toxicity, reduce biases, and align, those models with the customer's expectations. When it comes to privacy, that's actually is a different story. So we never use any customer's data for training models. The way the trust layer works in the Einstein 1 platform is that all the information, customer information, sits in Data Cloud, which is our own data platform, our infrastructure platform. And when there is a prompt, when there is a need for injecting some information, personal information, private information, this information comes from Data Cloud and is added to the prompt. And through grounding, through RAG, to these other techniques allows us to enrich the prompt, and then this gets fed into the model. And the model has a zero retainance. So it doesn't retain any information, any data that goes into the model. It's more like a faucet. All the water goes to the faucet. The only thing the model does is to regulate the flow of the model, but the faucet doesn't keep the water, right? So all the water goes through. The same thing here, through these policies we establish with the external vendors or with our own models, the data doesn't sit in the model, is used for training. So there's no risk that this data the prompt gets used by in training. So then this allows us to preserve privacy, confidentiality, and then eventually after the model produces an output, there's another layer that checks for toxicity, for biases, for hallucinations. There is some very important approaches and methods that allows us to assess the confidence of the model, to say, okay, I think that this is the answer, but I'm not sure 1%. In this case, I need extra human validation to assess the quality of the output. So these are some of the steps that we are making to ensure that we mitigate those issues as much as possible.
Silvio emphasized the importance of trust and transparency in enterprise AI. Data leaks rank high among National Safety Month hazards. Let's learn from an expert how AI is preventing them. Navindra Yadav is the CEO and founder of Theom. His team uses AI to protect sensitive data where it lives. In this clip, he explains how natural language processing helps detect personal information, assess its value, and block unauthorized access. What's the hardest problem that you and the team have solved so far?
The first and the hardest thing is this is a paradigm change, because now we're protecting data wherever the data lives. So how do you move along with the data into each one of these data stores without scaring people about, oh, there's now some engine running inside my data stores? So the whole technical challenge of implementing that without people installing agents or anything of that sort, without installing proxies, was the biggest technical challenge. And that's where a lot of the IP that Theom has built resides. Second thing was how to do this in a cost-efficient manner, because now we are crawling all of the customer's data inside their environment. Everything lives with the customer. So think of this as Google built for an enterprise, but runs inside the enterprise, because it has to crawl and figure out, okay, what's happening to the data and so on and so forth. That was the hardest technical challenge. The first one being run it wherever the data is so that we don't get bypassed. And the second part is about maintaining the cost structure and no data leaves the customer's environment.
I referred in the intro to assigning a criticality score to data. Is that something that the customer manually does, or is it semi-automated or fully automated?
It's fully automated. So what these crawlers essentially do, or this analysis essentially does, is it classifies the data, figures out whether this piece of data, it breaks them down into small pieces of tokens and figures out, okay, what this token maps to. For example, a really simple toy example would be, this is a credit card number, or this is social security, or this is something that's specific to the healthcare industry, or specific to the financial industry, or this is a trading pattern, or so on and so forth. Depending upon the industry vertical, we automatically default what the criticality of this item should be. Further, what Theom also puts an estimate around is the dollar value of that data. So we look at the dark web and see what are attackers actually willing to pay for this data. What is this data actually trading for, and so on and so forth. So that forms the seed of this pricing information for Theom. So Theom now starts attaching dollar values to different assets. This is the lower estimate that we put on the data and tell the customers, okay, this is at the minimum what we believe your data is worth in this particular store. And again, customers can drive their own APIs and make it more our APIs, and hit our APIs with more custom information, and then we can price it more appropriately for their environment. So really, criticality of the data and the financial value of the data is what we expose out to people. Why it becomes interesting is now CIOs know what cyber insurance they should be taking for different stores. Are they underinsured? Are they overinsured? It leads to all those interesting conversations from there.
That single use case of being able to identify or essentially label data based on whether it's a regex or something like that, to figure out if it's a credit card number or a birth date or an address or a phone number, things like that. Whole companies are just doing that. Talk us through,
I've spent some time on this problem. I mean, it's actually a very hard problem to solve when you look at spanning geographies and, there's all sorts of complicated parameters. How mature is that ability to, before we even get to the dark web and the value of the data, how mature is the technology of being able to accurately assign a label to it?
Great topic or great point. What we see in our, we're using the same technology or similar technology that ChatGPT and others, BERT transformers and so on and so forth use. So we are using these besides regex and things. Regex is good, cheap, good for some sort of problems. What we do is we bring NLP into this equation. We try to look at the context of the data. For example, someone says, the last 4 digits of my SSNR or last 4 digits of my social R or things. So now when you look at that context, you see 4 numbers, this is social security number because the context of the string or this unstructured data said something about that. So we let our NLP engines detect things like that. So wherever they pick up things, it's all depends on your training sets and how well they've all been crafted. That's one. There are other things we actually do whenever we find something, like classic examples are credit cards or ISINs. We do a LUN check on top of it. So in this industry, there are CRC checkers where we do semantic analysis of the data. And then we say, okay, this truly is a valid credit card number because it's passed this particular LUN check and so on and so forth, and we feed it in. So we do a whole bunch of mitigation actions before we even report any piece of thing as a certain entity. All of this is essentially to reduce false positives. Are there zero false positives? No such technology exists, or as far as I know, exists. It's always this game of actually improving your training set so that you come up with better arguments. Whenever we see a human tells us, okay, you've gone and mislabeled this, reinforcement learning happens in our engines. So we take it and take it from there. That's really where we are at this point of time.
So the cost of a false positive would probably be that your financial assessment of the value of the data may be wrong.
That's correct.
Because you can end up assigning, right? I was thinking more about the cost of a false negative. If there is, let's say, financial data that you're not identifying, that could potentially be much more damaging.
Bingo. That's exactly what I wanted to say sorry, I interrupted you. But yes, false negative is my worry. When they have something really sensitive and we did not classify that as really sensitive, that's the risk around that. So we put quite a few guardrails around this, and that's where it goes into our thing to try and reduce our false negatives as well as false positives. It's all about precision and recall. Again, it's a constant game of improving the product and taking it for that.
We've explored how AI can protect data and prevent system failures. But what happens when the models themselves introduce risk? Meet Eric Siegel, founder of Predictive Analytics World and author of the AI Playbook. He spent his career examining the unintended consequences of AI in high-stakes decisions. In this segment, he unpacks why predictive models often mirror human bias and why transparency and fairness must be built in from day one. Learn how AI guardrails turn risk into resilience.
My ethical concerns are in the predictive area, which has been the main focus of my career, and it has to do with civil rights. Is the model making discriminatory decisions? Because all of these operational decisions it's driving can potentially be very consequential. It's not just optimizing business and number crunching. It's governing. A model that makes predictions on a per individual basis is essentially a kind of a mini policy that's then either directly informing, maybe being the deciding factor for, or in some cases, literally, as I discussed, automating decisions. And if it's making decisions that discriminate based on protected class like race and religion, ethnicity, or is showing a certain kind of bias, and people call it machine bias. And there's a famous ProPublica article called Machine Bias that's very often cited, where the costly errors, and the model's going to make errors just like humans do. It's just hopefully it'll make fewer of them. It's not a magic crystal ball. But if the errors that are costly, such as that end up keeping somebody in jail longer or denying them credit or housing, happen with higher proportional frequency for certain underprivileged protected groups or racial groups, for example, than other, from one group to the other, that's a really serious civil liberties concern. So I've actually taken a lot of interest in that, written a bunch of op-eds in like the San Francisco Chronicle and the Scientific American blog. I put them all together. There's like 12 op-eds. If anyone wants to read my work, I put them all together at civilrightsdata.com.
We'll link to that in the show notes. One of the things I frequently say is that AI and machine learning models are perfectly designed to replicate human bias. And a lot of eyebrows go up when I say that from people who, either are naive about the potential harm that AI models can create, or just choose to turn a blind eye. What's your perspective on as a data scientist, how do we mitigate the impact of having human bias seep into these models, given that, to your point, they can make predictions that have significant implications on, for example, who dies, who lives, who gets loans, who gets educated, things that really have a dramatic impact on people's lives.
That's the central question to sort of what I'm obsessed about in this area. And I think what you said, that's perfectly designed to replicate human bias, is spot on. But actually, guess what? It's kind of good news. And follow me on this. By putting it on the table and quantifying and putting a spotlight on exactly what it is, what you're seeing is a quantification of the injustices that persist because of the world as it stands now. The historical inequities that put some groups in less advantageous positions than others. Now that manifests, and for example, it manifests in the proportional rates of those kinds of costly mistakes that I was referring to. To put it into technical terms, what we're talking about is false positive rates, where it says, oh, this person's high risk of committing a crime again if we release them for prison. This person's at high risk of not paying back their loan. In the case that those predictions are wrong, those are called false positives or false alarms. If the false positive rate's higher for one group than the other. So by quantifying, putting a spotlight on it, then now, instead of it's a bunch of people doing it inside the human head, you can see my head on the video. I know we're not going to video here, but my head is the ultimate black box, right? We can't see into each other's minds or brains. What we can do is quantify what happens when there's this transparency. And although models can be opaque to a certain degree, we do have transparency because we can record their activity. So this provides us the opportunity to adjust for those inequity and actually implement for social justice in the way models are deployed. Now, unfortunately, that does open a can of worms. And essentially, the way you would adjust for the difference in false positive rates would be analogous to affirmative action. I'm pro-affirmative action. I see those differences in false positive rates as a manifestation of historical injustice. I see the opportunity to adjust for it, but doing so means reintroducing the protected class. So then the model might be colorblind in the sense of not directly making a decision based on race, for example. But you do need to reintroduce the protected category, just the same as with affirmative action, to adjust for it. So it doesn't eliminate today's polarized kind of political debate around the topic, but at least it helps us look more concretely at what the issue is and what we could potentially do about it.
We've heard how predictive models can magnify human bias. Now let's look at what it means to build enterprise AI systems that are secure, compliant, and useful. Ben Kaz is CTO at Box. In this segment, he shares how his team builds AI features that respect customer trust, avoid data leaks, and prioritize long-term value over hype. You'll hear why speed alone isn't enough. Real impact comes from finding failure points early and knowing when to slow down.
On this podcast, we talk a lot about the future of work in the context of what it means to practice AI responsibly.
Yeah.
And in the seat that you sit in, I imagine you're constantly thinking about the art of the possible, but perhaps constrained by not just what we can do, but what we should do. What does responsible AI even mean to you?
So for me, the word is a big and very important word, responsible AI. But in terms of what it means for me and my job at Box as a sort of a major user of AI, one of the key things for us is to make sure we're the content cloud, right? So we have hundreds of thousands of customers. We have hundreds of billions of files. We have hundreds of petabytes of data, and we're trusted to keep some of the most valuable data from these organizations and keep it safe, keep it secure, make sure it's used properly. And that's like fundamental to everything that we do. And then the moment, though, that you add AI to it, you just get these really giant questions, like these like really difficult, like, how is this going to work? I think a lot of people who are doing like not necessarily like enterprise focused apps, they sometimes miss this idea that like permissions are really critical and sometimes very hard. So for instance, let's say you have AI and it has access to all of your employee data. It has access to all of your financial data, including an upcoming earnings report. Let's say you have it like access to maybe an upcoming M&A deal you're doing. Like, what's going to happen when somebody starts asking the questions of the AI? Like, and we've seen people who go build their own thing, or like maybe companies that are smaller in scope, and they like sometimes just forget this really critical point that like every single person in your enterprise has access to different things, and AI needs to respond to that. And it can be hard. Like, you can't just train a model and expect it to figure that out. And so for us, we want to, when we're thinking about practicing AI responsibility, the first thing is to make sure that it is like safe and secure and its respect permissions. And we use this term enterprise grade, and that's a huge part of it. Like, enterprises, in many cases, the customers we talk to are very excited about AI. And they're also very scared of AI because of these kinds of challenges. It's so new that then the technologies are so, like even the companies are very different. And so you have to make sure that you're focused on, like, you do not want your AI to become the biggest source of data leakage that you've ever experienced. And if you're not careful, that can happen. Now, on the responsibility side, like, as people are using it, like, one of the challenges that as people are dealing with business critical processes and they're thinking through, the content that they have, workflows inside of Box and others, we often give them recommendations about what to do or what not to do. Even though we go out of our way to really make sure that the AI is not hallucinating, it's giving you very accurate answers. One of the challenges is it will be wrong. Like, everybody, like, no one should ever guarantee you that the AI is always right. Similarly, like no person is always right. And so some people, when they're thinking about like these kind of like decision-making processes, like we recommend don't use the AI to actually make the final decision on things. And to us, this is actually a big part of our responsibility, is to help train people on how to use like our especially our content-driven workflows. And we tell people, let's say if something's important enough that, like, a classic example would be like the AI is probably capable of looking at a resume and you're able to like give it like a bunch of information about like what you want from a candidate. And it can probably tell you whether it thinks the person's a good fit. But you shouldn't do that. You should have maybe the AI pull out some key facts for you, and then you should have the person make the decision. And somewhere along there is the line about being responsible with the current state of technology, while also getting the benefits from sort of the productivity and other sort of ways that you can work better using this new technology.
As technologists, we're so accustomed to only asking what could go right as we get excited about new technologies. And I think that this is the first time in decades when it's equally important that we ask what could go wrong. And as the leader of a technology organization, I just wonder, how do you think about the personal responsibility that you have to create a culture where you may be perceived as putting the brake or putting your foot on the brake in terms of innovation, but because you want to enforce that as a culture, you also espouse the principles of doing the right thing, not just doing what you could do?
No, I think this is one of the benefits of being at a company that takes very seriously what our customers trust in us, right? We have some of the most important things in their company. So we take that very seriously. And to me, the concern that we have is a little bit less of, are we going to do something irresponsible? That's very much in the culture. It's one of our key things, is to not do harm in any of these ways. It's just, we're enterprise grade from that perspective. But then the other part of it is sometimes you get the new technologies are so innovative and so different that you sometimes you sometimes just try to keep doing things without necessarily thinking through like how this will end up. And to me, this is one of the things that, like, for AI, like, it's just this common thing, is that like normally when you're building stuff and you have new features or whatever, you have a hackathon, you're thinking of new ideas, it takes so long to get something that actually works and works well. And with AI, like generative AI, it's very fast. You almost collapse the first like 60% of a product development cycle into a day or two. And that, I think, throws people off sometimes, because like then they believe that, oh, it's so close to being done, then let's just keep going and finish it. And instead of a lot of the work in making a really good AI-oriented product is around what happens next. What's the quality of it? What's going to happen in the corner cases if something goes wrong? Is it actually giving you what you want? Even though the demo looks cool, keep trying it. Try to get it to fail and then explore where the failure boundaries are. And that's because generative AI is somewhat probabilistic. It has that sort of that challenge that you have to manage.
National Safety Month is a reminder that progress in AI isn't just about speed, it's about responsibility. Whether it's protecting sensitive data, detecting bias, or building resilient systems, safety must be designed into the process of evaluating and deploying AI models. If any of these ideas resonated with you, listen to the full episodes. Links are in today's show notes. And if you know anyone who needs to learn more about AI safety, pass this one along or let us know in the comments. Thanks for listening to this special edition of AI and the Future of Work. Until next time, stay safe and stay curious.